friends. In previous few sessions of material testing and evaluation course, we have studied about various conventional materials used for construction activity. Now, in this session, we are going to discuss about a very new topic and modern material used for construction activity in the form of 3D printing. Myself, R.V. Zugdar, Assistant Professor in Civil Engineering Department, Sharad Institute of Technology, College of Engineering. In this session, we are going to discuss about what is 3D printing, how it is implemented in construction field, steps involved in 3D printing, and recent examples of 3D printing buildings. What is 3D printing? As name itself suggests, it is printing done in three dimensions. Means it is done in X, Y, and Z axis. 3D printing is a form of additive manufacturing in which components are fabricated in an additive fashion by adding successive layers of material together. Means as like a regular printing, in a 3D printing, the layers of the prefabricated additive is spread like wall component, brick component, or any other components of building. This consists of following phases. First is modeling phase. It takes virtual blueprints from AutoCAD, slices them into digital cross sections. The next phase is printing. It reads the design and lays down successive layers over the drawing. It joined together or automatically fused to create the final shape of the structure. And the last phase is finishing phase. In finishing phase, a removing material with a higher resolution subtractive process is done. The following flowchart shows the 3D printing work. The 3D printing starts from CAD 3D modeler, after which it is converted into STL file, and then slicing application is com- given to command. After that, the layer spacers and tool paths are given to the printer, and after giving commands to the 3D printer, the 3D object is created by various movements of the nozzle of machine. Printing machine features. There are various features of printing machine: motion along the axis, mecha- mechanics or machine design, nozzle design, tank and pump design. Machine design: cementing materials as concrete. The machine had to account for both the fresh and printed properties of concrete. 3D components: the concrete tank and pumping mechanism, the printing nozzle, and motion control systems. Tank and pump design: to transport the concrete paste from the tank to nozzle, it combines syringe pressure methodology and cement screw pump. Tank is a cylindrical mobile nozzle connected to the machine and moves with it. Bottom of tank is printing nozzle. Most element considered is the pressure exerted by the pump, which affect the speed at which concrete being poured. Nozzle design: Nozzle diameter has direct relationship with the concrete mix properties, especially its flowability is main issue. As diameter increases, flowability of mix should be increased. It has two trowels, a side and top trowel, which lag behind it for straighten the concrete. The following figure shows the nozzle printing. Motion along the axis. The machine is designed to move on a trial axial plane XYZ. The nozzle should be able to print in one line alone on the longitudinal axis x-axis and move along the perpendicular axis y-axis. It should able to move along z-axis to print layer upon layer. Vertical elements that support mobile tank and nozzle is responsible for motion along the axis. It is operated both hydraulically and manually. This is example of printing machine, how it works for building construction. The green color machine shows the printing machine and it prints the building layer by layer in X, Y and Z axis. Assembly of printed components. In generally, the components are manufactured or printed in yard and they are then installed for the structure or construction of building as shown in the photograph. Assembly of printed slab is installed after completion of wall construction and assembly of wall with column. Computer crafting, sorry, contour crafting. Material is poured layer by layer. Whole process is taking place on site, allowed to create large component with unlimited architectural flexibility. The following photograph shows the existing structures made by 3D printing process or technology. Recent examples of 3D printing. Vincent Company building is constructed by using 3D printing technique as well as the 5-story building printed in 3D. Merits of 3D printing. It optimizes construction time, design flexibility, does not compromise structural strength of building. The error is reduced due to modern technology. The environmental aspects due to such kind of construction are very good as compared to conventional construction methods. Concept of contour crafting allows in situ printing, reduced number of injuries. It has less material waste as compared to conventional methods of construction. Demerits or disadvantages. There are job related issues like material shortage and machinery problems. It requires area for movable re- retractable rails. It cannot print all materials. High limitations for contour crafting is the main issue of 3D printing. Now, in this session, we have discussed about various things regarding 3D printing, and from that, we can conclude that still young and present lot of limitations. New architectural approach to building design is due to 3D printing is occur. Require development of new materials appropriate for 3D printing and allows creating building with complicated shape is possible due to 3D printing technology. Now we will see one video of 3D printing mechanism.